What is the biggest advantage of a local first database?
You can just write data locally, push it up to the server, and pretend you don't even know the backend exists.
Hi, and welcome to PodRocket, a web development podcast brought to you by LogRocket. I am Paige Niedringhaus, and today we have Ben Holmes, a product engineer at Warp, here to talk about putting your database in the browser. In this episode, Ben and I talk about what does local first architecture mean for web applications, some of the benefits and the challenges of putting your database in the browser, and how to keep data in sync on the client and on the server. So here's our episode with Ben Holmes. Hi, and welcome to PodRocket. I am your host today, Paige Niedringhaus, and we have Ben Holmes, product engineer at Warp, here to talk about putting your database in the browser. Welcome back to the show, Ben.
Hey, yeah, how's it going? I don't know if this is round 3 or something for us. It's been great to come on here with all the stuff that I've been doing on my dev journey for a while now.
I mean, we enjoy having you and hearing what's new, so let's just jump right into it. So you recently came off of a talk where you talked about databases in the browser, and one of the things that you touched on early on was how does latency impact web applications, and why does it become a bigger issue as an app starts to scale globally?
Yeah, so we did a quick Excalibur sort of explaining this, but to explain with my hands. So, like when you're building an app, you usually start with just a central server, a database, and some clients that talk to it. And since the dawn of time, that's how servers have been built. You deploy to one region, you put it on a box. Nowadays, it's a Docker container, and you connect to whatever region that's in. And of course, that can be an issue as you onboard more users internationally or just in other regions. If I went to Amsterdam to deliver this talk, and if I'm trying to talk to an application that I developed when I was back home, then I'm probably going to run into some network latency up to half a second. So I need some way to improve either reads, writes, or both. You really just need to think about what data access patterns your app has to figure out how to solve that latency issue. Usually, when you're trying to address this, you're building more of a read-intensive application. At least in my experience, you're going to be reading data more often than you're writing it if you're building web apps. So everything from documentation sites that you might build with Astro, a framework that I worked on for a while, up to even Twitter. Like people read tweets far more often than they actually post. In all those cases, you can usually get by creating a lot of read replicas of your data in whatever regions your users are typically accessing them from. So that could mean creating just CDN level caches for whatever assets you have in your app. That's pretty common for the actual images or videos that you might be loading within a post, for example. But it's also true for more dynamic data. You might put a Redis cache in multiple regions or SQLite files duplicated wherever users are typically visiting your site. So that way, when you're querying for stuff, it's going to read very quickly. And you can still write data. That's going to have the same latency issues that you might run into if you only have a single region for all of your writes. But for most applications, that's totally fine. And you just write to the single region, hopefully with some backups so that you can handle downtime. And then it'll distribute out all the data that you wrote to that single leader, as it's called. Single leader replication is what model we're talking about. You would write to that single leader, and then it would duplicate that to all of the caches. So there's always a source of truth. You're not worried about merge conflicts, or you wrote to a local database, and then someone else wrote to their local database, and now we need to come together. So even though we're talking about database in the browser, I feel like for a lot of people, getting by on read replicas is a smart way to solve this problem. It's only when you're running into a very write-intensive application where you need your writes to be very snappy as well. When you're in that situation, you need to explore other more exotic architectures, like putting a database in the browser or multi-region replication, however you end up tackling that.
Let's talk about that. So, one of the things that you talk about is a local first architecture, which has been getting a lot of press lately. People are talking about local first applications and being able to work offline and then have it sync when they're back within range of
Yeah.
Wi-Fi or internet. So, how does that change the way that data is managed in a web application?
Yeah, and it's funny because local first, like as a concept, has existed since the 90s. So, like if you build a calendar app, it needs to work offline. It's probably using SQLite, which has been around for decades. And it has a sync engine to resolve whatever issues when you come back online. But up until now, or up until the past few years, it wasn't easy to do that on the web. If you wanted to create a local data cache, for a while you just had local storage, and then there was IndexedDB, which is the browser's built-in solution to query things quickly. A little nuance in the difference. IndexedDB is a more robust local storage that lets you index specific entries inside of it. So if you wanted to query for all the documents with a given author, it would be able to search through the index instead of pulling all of that into memory and trying to search it. So for larger data sets, you would reach for something like an IndexedDB. But the problem is IndexedDB is a very distinct API. People usually use wrapper libraries to understand it better because it
Yeah.
is very hard to work with. And you're still working with a document-based data store. Most people use SQL on the back end. So switching to a document model is like having a MongoDB database and a SQL database and having them duplicate across each other. It's hard. It's hard to do. But it's certainly been done because IndexedDB is built in and there's no cost. So we were in this talk exploring what it would look like if you did reach for SQLite in the browser,
Mhm.
which has only been possible recently, since there's a way to store files in the browser now that doesn't require asking for user permissions. Like you don't have to say, I want access to your documents folder to start writing data. Now browsers have a private sandbox called the Origin Private File System. And this is now like very green on Can I Use if you're at all skeptical. It works in Safari, Firefox, all the other ones, mobile Safari. That's the important one. So now you have this like area where you can store all of your files. So if you wanted to stand up a SQLite file and read from it in the browser, you
Mhm.
can totally do that. If you combine it with a bit of WebAssembly to actually make SQLite queries, it works really well. And it's officially supported by the SQLite.org. You can go there and see the SQLite WebAssembly build to put SQLite on the web. And Origin Private File System is documented by the Chrome team and MDN. So you're in good hands to learn all these technologies, and it makes for a very tight experience where you can reuse what queries you might have been writing on the server and reuse them on the client. And also
Yeah.
for your database schemas, the same thing. If you have a table of issues that you store
Mhm.
on the server, you could create a table of issues on the client, and you can manage the migrations between the two using similar technologies. Especially if you use JavaScript on the back end, it means that you can reuse your JavaScript code between the two environments as well. So it's just a nicer way to share server and client tech without having to reinvent around browser specific APIs.
So you've talked a little bit about it already, but how does moving the data closer to the client improve that performance and responsiveness?
So when we're actually duplicating data into the client, that usually means you want to be able to write data on the client as well. So you don't need to make a round trip to the server to make sure the record is created before you can update the UI. It also
Mhm.
means you don't need complicated tricks to do this in memory with like React storage solutions like Redux. You don't need to create any of those data stores. Instead, you can write updates to your local SQLite file and then write a sync engine that takes whatever updates are coming to that local file and tells the server about them in the background. And if it
Mm.
comes back and there's an error, you can show a toast notification, rollback state, however you want to handle that. They're very complicated nuances, of course. But once you create that sync engine, the beauty is you can add new features to your application without any updates to your server side functions, really. Because instead of having a function for every action a user is going to take, you just need set of endpoints to actually sync whatever updates happen on the client on the server. And the two endpoints we implemented were push and pull. It just like GitHub, you would have an endpoint to push whatever updates happen to the client-side database and pull down whatever updates the server can tell you about. And from there, you can do whatever you want inside of the database. You can create new entries, you can update, you can delete, you can write complicated select statements with indexing to create new views in the application. And you don't need to touch the backend. If you're a front-end focused developer like me, you're very empowered to just add a lot of new features without even needing to cross the boundary and without having to wait for the server updates to happen before you refresh the UI. So there's a lot of appeal to it, both from a mental model standpoint. It's a lot easier to think, I'm just going to make some updates on the client side code and the server will update. But also from a latency standpoint, now we can read our own writes and we can see the results without having to wait for the server to acknowledge it. Again, that means you need to handle rollbacks, authentication, etc. So you're moving complexity somewhere else. But there are a lot of batteries included solutions today where you don't really need to solve them yourself. You can kind of reach for best practices and then just handle all of your application logic client side for the most part.
Yeah. And that's really exciting because I remember when some of the other data fetching libraries like SWR and those sorts of things came out, their thing
Yep.
was all about optimistic updates, which was very cool because the browser looked like the way you wanted your server and your database to look, but it could still fail in the back end. So the fact that you're updating the front end and then just pushing it back afterwards takes away all of that complexity and the optimistic part of it.
Yeah, it's the optimistic part because I've been following React 19. I've seen the new use optimistic hook, and so I also played with TanStack Query, which implements this as well.
Yeah.
And it's a lot of boilerplate to figure out, okay, how am I going to store the local copy of this data? How am I going to optimistically update it? What happens on success and failure? And you need to resolve that problem for everywhere in your app that you're doing this. I
Mhm.
do think there's ways to make those APIs more streamlined, and I think that is the goal of tools like TanStack and TRPC. I think has a lot of built-in solutions for that. But it's a different mental model. It's a lot more you have to juggle when you have loading states and you would rather implement your own stuff on top of it.
All right. So, I mean, we just started to talk about this, but what are some of the challenges that arise when you're trying to synchronize local changes across multiple clients and still maintain data integrity?
Yeah, and we only scratched the surface if you go look at the repository we built. I open source the work. It's as simple sync engine. And it really is simple. Like the few of the problems that you run into right away are how do you smartly send client updates to the server and then pull down whatever updates other clients are sending? Because you need to think about not just what records were created by other clients, but also what order they were created in. If you're using auto incrementing IDs, what's the ID supposed to be? And you need someone to reconcile who wins whenever a record is updated, for example. And there's whole areas of research around that. We just went with the simple solution, which is last write wins. So
Mm.
whoever the server sees as the last person who updated an entry is going to win out on whatever that is. So two people visit a Wikipedia page, they both change the title and hit save. Whichever one hits save last, according to the server, so whatever network latency there is, whichever is the last request, that's going to be the last update in your log. And that's going to be propagated to all the other clients. So in this model, you're thinking of it like there's a source of truth. So we don't really talk about offline mode, but we are thinking about, okay, whenever people send updates, the server's going to have the source of truth of which updates happened in which order. And
Mhm.
then it's going to send to each client what updates that it knows about whenever that client pulls for updates. So you might be smart and use WebSockets for that. So it's pulling whenever the server sees something new. You can
Right.
also use just polling every 2 seconds if you want to have something that is more like server agnostic and you don't need to implement WebSockets.
Yeah.
It's easy enough to just ask Claude add a WebSocket. So maybe you should do that. But however you want to do it, you wait for the server to reconcile all the updates, you pull it down, and then you hit your next challenge, which is invalidating the updates you made. You make some updates locally, you pull from the server, and you need to see, okay, which changes did the server acknowledge and which ones did it not? I made 3 updates locally. I pushed them to the server. Now I pull down data from the server and I see, okay, 2 updates were made by this other client. So I'll just pull that into my database, no conflicts there. And then I see it acknowledged 2 of the 3 updates that I pushed up. The third one is still waiting because of network latency or some other reason. So
Mhm.
you need to say, okay, it only acknowledged the first 2 of my requests, not all 3. So I need to flush out the first two requests that I made locally. And then the third one, I need to kind of replay on top of the server update. So if you think of it like a Git rebase, it's a similar thing where you rebase on top of main and it has two of your three commits. So naturally, you have your three commits, you pull from the server, you rebase the two commits that the server acknowledged, and then the third one gets added to your branch. So now you're like
Mhm.
one commit ahead of whatever the server had instead of three, because now you've
Yeah.
pushed everything up. Again, if you want to watch the talk and see visuals, that's useful. But that's the general principle is you're rebasing on top of whatever state the server has. And you're invalidating your optimistic updates as soon as the server acknowledges that they were successful. And you can merge
Mhm.
them together just with like incrementing IDs. You can have unique IDs for every mutation you make. So that way you can see commit hash whatever was acknowledged by the
Mhm.
server. Go ahead and invalidate that. However you want to manage that, as long as you're rebasing, replaying stuff that the server hasn't seen before, you should always end up in the same state across clients. That's really the important thing is you don't want two different clients to have two different ideas of what the server looks like. The server is always going to have that one main branch of all of the updates that were made, and the client will constantly pull down that main branch and rebase their work so that everything is up to date how you would expect.
Are there any practical limitations of using a SQLite browser-based database for a web app like this that people should keep in mind?
Yeah, most of the questions that I've gotten after this is authentication and security, which is a very
Mhm.
important one. Since we're talking about replicating data in the client more aggressively than you typically would, because now you're storing to disk and you're also duplicating whatever tables you're allowing the client side database to duplicate. So, first, you need your basic authentication checks in front of whatever endpoints are pushing and pulling data. But you may need to get more granular about which tables are replicated on the client and which are not. And even more granularly, which rows the user might have access to within those data stores. And depending on how granular you get, I would point you to other frameworks that kind of solve these problems, more batteries included. The RashiCorp team is a team that has built some of the most robust libraries in local first out there. One of them is Replicache, which is the push and pull model that we've been talking about. They implement that as a framework, so you don't need to implement it yourself, and it'll have all these best practices. But there's also a new framework they're creating called Zero, which introduces row level permissions for all of your data. So you can very granularly say, if the user is authenticated, they can read but cannot write from this table. You can
Mhm.
say all the CRUD operations are allowed to do, the visibility of it, and Zero will smartly sync what data is allowed to a given client based on whatever authentication check you have. So when you're handling what data should be duplicated in the browser, that's the most delicate thing that you really need to think about. And the second one is just bundle size. When you're using IndexedDB, that's going to be built in, so you won't have any bundle issues. It's just the complexity of using IndexedDB.
Right.
But when you reach for SQLite, you're going to need to bundle the WebAssembly builds.
Mhm.
And that usually means half a megabyte of data, give or take. And for a lot of applications, that's pretty small and it's very usable. If you're building email clients or an issue board, downloading half a megabyte of data is not really a big deal, since usually your JavaScript bundle will be of a similar size. But if you wanted to use it for implementing a search bar on your documentation site, for example, that's common
Mhm.
if you're using Astro and the Starlight framework. SQLite's probably too heavy-handed because it means everyone who comes to your website from Google or whatever search engine, they're going to have to wait for SQLite to load before they can start searching. And that can be a lot of latency, could be some CPU cost as well to execute SQLite queries. So you just need to think, is this too heavyweight of a solution for our problem? If
Yeah.
you're in that sweet spot of you're making a lot of writes, you're a very interactive application, then it's probably worth it. But if it's just for a few touch points on the app, you're probably better off using like a local storage solution. Starlight for our documentation search, it's just indexed JSON file that's generated at build time and then
Mhm.
imported in the browser. It's another way to do it. Just search through a key value pair, and if it's a scope size, it'll probably be good for whatever
Yeah.
you're doing. So just be aware there's like a performance cost and a bundle cost. And if you're a more write intensive application, that's probably fine.
Cool. So, what are some of the key principles behind building a robust sync system for local first applications?
Yeah, if it needs to be robust, it starts with like data integrity. So you've got to have a source of truth of whenever updates are made, this is the order that the updates occurred in. So all the clients are on the same page about what the end state looks like. You can't have any client that's out of date or anything like that. And you also need to think about just the network cost of syncing all of these updates. In our solution, we used an event logging system which really just logs a history of events since the dawn of your server, like every single update that any client has ever made. And when you need to bootstrap a new client, you need to import all of those logs, which will get longer and longer as you go. So you need some way probably to compact related operations. Like if there were 10 updates, you could probably compact it to the last update that occurred. Or you can just approach it with different methods. Replicache, which is the library I mentioned earlier, they recommend using a different way of sending updates called just data snapshots. So instead of sending a running log of every update that was made, it just sends a snapshot of the data and diffs against your local copy. And then you can figure out what changes need to be made against your local data in order to reconcile or rebase against whatever the server has given you. It's very difficult to implement that flow if you're using like a full-on SQLite file, because diffing two SQLite files, like I'm sure there's libraries for it, but it's
Yeah.
crazy. Yeah, Replicache skirts around it because they just support key value storage. So you can't have complicated table schemas. You can just have
Hmm.
key value. So they can
Yeah.
easily give you a diff of what the keys and values are so you can reconcile that. But it is definitely something to think about. Like, how are you storing all of these updates? How can you performantly diff against whatever updates the server has? And also, when you're onboarding a user, how can they pull down the state of the world without it being a very long and crazy network request to replay? That's just scratching the surface of problems. You can also talk about like handling merge conflicts. Sometimes last write wins just isn't the way to go. If
Yeah.
two people are updating a Google Doc, you can't just take the last person who edited it, because if someone comes off of a flight, they were editing a document offline for 3 hours, they come back online, they'll just blow away whatever's there because they're the last one that connected. There are other mechanisms for that called CRDTs, which is
Hmm.
it's a document that can merge with another document without having conflicts ever. So you could take two Google Docs, it'll merge them together whenever the person's back online, and
Hmm.
it'll smartly figure out, okay, they updated paragraph 3, this other person added a paragraph above it, so I'll just include both of your changes. I'll include that
Hmm.
new paragraph up there and your updates here. If you're updating the same line, we'll actually go character by character and really figure out what the update should be. It's a very complex algorithm, but at this point, there are libraries that can solve it for you. So if you're into that situation of, I just need really strong document merging, which is
Yeah.
common for anything that is related to editing. YJS, that's a popular library for this sort of thing, so you don't have to implement it yourself. But there's a ton of actual theory out there if you want to go researching.
Nice.
Yeah, I haven't done the deep dive myself. I've just listened to podcasts about it. But I've heard from these academic researchers that really have tried to find the perfect algorithms for these things. It's definitely a bit of knowledge worth having if you're going to build a document editing service.
So, along those same lines, do you have any strategies to help prevent issues like duplicate records or overwriting data when multiple users are making updates beyond these algorithms and kind of the things that the very smart people in academia are talking about?
Yeah, if you're trying to reconcile updates to the same document, usually a CRDT is what you need to do. And you don't
Hmm.
need to be smart to use them. YJS is very friendly at this point. They have example packages to stand up servers to sync all of the data. So you don't have to build the sync engine part either. It'll just handle syncing up documents, reconciling updates, and pulling back down. They also have adapters for other languages. So YJS is almost a misnomer at this point, since it can be used in Elixir, I think PHP, and a few others. If anyone wants a CRDT, they're going to go build it. So that community is growing pretty quickly. As for duplicate records, you really just need to be careful about how keys are generated. I actually made this mistake in my sync engine implementation where I just use SQLite's auto incrementing IDs.
Mhm.
And that means when you're creating a record on the client, it may create an ID that gets overwritten by another client creating an entry of that ID. So you end up like accidentally updating a record that another client wrote because they both generated something with an ID of 9 when they tried to
Mm,
push up. So you need to be smart about how do you create unique identifiers, preferably on the client, but also with a server side check to make sure you're not generating a duplicate.
mm,
It's difficult because you normally should not trust data coming from the client. But here,
right.
based on the implementation, you kind of have to generate IDs on the client. You will need some way on the server to validate this is a good ID, like it follows a UUID specification, it looks right, and also it's not going to conflict with whatever another client has sent. A common way
Mhm.
to do that is to assign IDs to each client whenever they connect.
Yeah.
So you can scope your IDs and say, this client with this hash that the server generated told me about the ID of 9. And then this other client with a different hash told me the ID of 9. So I'm just going to concatenate those together and say client hash colon and then whatever ID they prefer. So
Mhm.
that way, all of your IDs are scoped to whatever the client ID is. So the server can prevent duplicates from happening by assigning you a designated ID to prefix all the things that you're creating.
Oh, got it. That's a good suggestion. So, Ben, where do you see the future of local first development going, and what upcoming technologies can make it even more powerful than it already seems to be?
I think local first is seeing more adoption because first there were a lot of web apps that shook up what was possible. Like when everyone saw linear enter the scene as an alternative to Jira that felt a lot faster while also being a web app, it sort of revealed there are ways to make native feeling applications in the browser. And there are other examples of that, but linear was one that was mentioned more often because they're more public about the architecture they used.
Mhm.
They have talks about how the entire linear architecture works. And it's been enough of a resource that people have created open source repos reverse engineering how linear works. So if you want to go learn about that's also something that you can go find. Wenzhou Hu, I'm not sure if I'm saying his name right, but he built a reverse engineering of linear that you can go find with a simple Google search of just reverse engineering linear. Yeah, so it's all out in the open now. That's really what
Yeah.
changed. This has been possible for a long time.
Mm.
It's just been a lot clearer recently how you might approach the problem and how you would resolve conflicts. I have heard that people still tend to roll their own sync engines when they hit a certain amount of scale or just
Mhm.
from the get-go if they have experience. I know the linear team has looked at other libraries and admitted, yeah, we have to stick with our hand-rolled solution. We can't reach for libraries like Zero, which I mentioned before,
Yeah.
because we have very specific needs. There are frameworks that are making it very batteries included, and I would at least encourage people to start with those. Replicache is the longest running one. It's from the Google team or former members of the Google team that have worked with browser storage at IndexedDB for over a decade before going off and creating a library. So they have a
Mhm.
lot of field knowledge. At the very least, reading their documentation to see how you approach the problem is super useful. So learning about that technology is a great starting point. And their work on Zero, which is a newer batteries included option that lets you run SQL queries in the browser, that's one that I've been experimenting with recently. And it's still an alpha. It definitely has performance hiccups and like weird issues in validating caches when you're redeploying changes. But again, their documentation is so robust about all the problems you hit and all the ways they recommend solving it that it's worth trying the library itself. And then if you need to build your own, use the docs as a learning framework to go off and implement a sync engine. So start with those libraries. I think they're amazing. YJS as well, if you need to work with document storage. They have very robust solutions for this now. And my own repo, Simple Sync Engine, is meant to be a springboard for where you can actually inspect the code and understand what's going on. So bringing the docs of Replicache to life with some code. So you can actually see how at least the surface level problems can be addressed. So all of those are good homework if you're interested in this sort of stuff. Otherwise, feel free to ignore it. I don't want to overprescribe local first onto a lot of applications since it really has its pocket in like interactive, write intensive apps. So think task boards, email clients, calendar apps, anything that is similar to that category. It's worth learning about.
That's all great advice, and it sounds like you've given us some really good resources to go get started if this is something that people are interested in learning more about. All
Yeah,
right, so
totally.
let's go into the quick round before we wrap things up. So, what is the biggest advantage of a local first database?
The fact that you can write data, you don't need to write a bunch of server endpoints and optimistic updates to handle things on the client. You can just write data locally, push it up to the server, and pretend you don't even know the backend exists.
What is the most common mistake that developers make when implementing a sync system?
Thinking they need to implement it themselves. Probably go try a library that explains these concepts and then roll your own once you find the need or grow out of it.
Good advice. And what is the biggest limitation of SQLite in the browser?
Bundle size, because you are going to need to load up a WebAssembly file and query it directly. So only reach for SQLite in the browser. If you're building an intensive app, the bundle size isn't too important, and you really see the benefit over browser-based solutions like local storage or IndexedDB.
Ben, it has been great having you back on the podcast. Is there anywhere that you would direct people if they want to get in touch with you to talk more about Simple Sync Engine or just learn more about what you're doing in general?
Yeah, my profile handle is bholmesdev, so Holmes as in Sherlock Holmes. Everywhere on Twitter and Blue Sky, I'm very active, YouTube as well. And if you want to go find the learning resources for Simple Sync Engine, you can go to GitHub, bholmesdev, and you'll find it as one of the pinned repos over there.
Great. Thank you so much again for coming on. It's been great talking with you.
Yeah, you as well. Always good joining you.